Hello and welcome to another tutorial. So today we're going to be going over how to interact with smart contracts via the dapi in your website. So in the previous tutorial we talked about how to get started with the dapi when making connections to the Ontology blockchain. So if you haven't already watched that, I would go back and watch that one before you continue with this one. You can find this and other tutorials in the Ontology Learning Center by Tower Builders at learn.towerbuilders.org. So when you're interacting with smart contracts via the dapi, there are two basic methods that you're going to want to be concerned with. They're going to be invoke read and read. You can kind of think of these two as like a read and write. And so anytime you want to read information from the blockchain or execute a function to know what the output is before actually asking the user to sign the transaction, you can use invoke read. Anytime you want to actually have the user sign the transaction, broadcast it to the blockchain, and have the results change the state of the blockchain, you're going to use the invoke function. So let's first go over invoke read so that we can get some information from a smart contract. So if we take a look at the test bed here, if you scroll down to the invoke read section, you can see that there are three different parameters that we need to concern ourselves with. The first is going to be the script hash. This is going to be the hash address of the contract that's deployed on the blockchain. The operation is going to be the method in the smart contract that you'd like to run, and arguments is going to be a list of arguments that you'd like to provide to this method as inputs. So you can see here that once you fill in the parameters and click invoke read, the results will return immediately and not query the user for their approval, because just like calling get balance, this doesn't necessarily have anything to do with the user's wallet, and it's not very specific to their account. It's just a read operation that is going to query the blockchain for a given state. And so upon a successful return, you're going to get an object with 4 different attributes. The results are going to be state, gas, results, and notify. For the purpose of this tutorial, we're just going to concern ourselves with the result, and we'll talk about the other ones in a different tutorial. So the very basic call that we can do is querying the balance of a given address for a OEP4 or a token contract. So to get a full list of the OEP4 tokens, you can look at the ONT Explorer here at explorer.ont.io. So once you have the script hash of a contract that you'd like to query, paste it here in the script hash section. For this part, we're going to choose an operation of balance of. What this is going to do is it's going to take one input parameter, and it's going to just check simply what is the balance of these tokens for this given address. So here in the arguments, we're going to have an array of objects, and these objects are a standard format where it accepts a type and a value, where the type actually describes what data type is included in the value. So for the purpose of the JSON, they're all going to be strings, but this is important because when it gets translated into a transaction by the wallet provider, depending on what type you choose, it's going to transform the string in value to be compatible with the transaction that you're trying to broadcast, whether it be a read or an actual invoke. So in this case, we're going to use a type of address, and for the value, we're going to use an actual address. And so, as you can see in the result here, this is not really a number. The reason for this is because all the return values from the Ontology blockchain are going to be in hex string format. And so that's important because anytime you want to display this information to the user, you're going to want to use some kind of transformation. So for this in the test bed, you can go down to the bottom right hand corner and click on the utils button. What this is going to do is it's going to open up a side section called utils, and it's going to have a list of common transformations that are actually available for you on the dapi. And for this case, depending on the method that you call, you're going to either expect that the result is going to be a string or an integer, but formatted as a hex string. So in this case, because it's balance of, we know that it's going to return an integer formatted as a hex string. So you can use this converter here on the right side, paste the result into the hex string input, and click transform. And upon clicking the transform button, you're going to see here that the output is a very long integer. And you may think that this is not accurate because this is a lot of decimal places off, but the reason for this is that all the numbers in smart contracts are going to be dealt with in integer values, And so it's important to know that, because when you want to convert it back to be a human readable number, you need to make a secondary call to the token contract for how many decimal places that token has, and you can use that in combination with the value returned as a hex string to format it properly. So now that we've gone over an example in the testbed, let's take a look at what the code for this looks like. So if you want to use the invoke read function, it's again going to be on the ONT namespace, but this time under the SC sub namespace, and it's going to be a function called invoke read. Again, this is going to take a single argument that's an object with multiple parameters, and in this case the parameters are going to be what network you want to read from, the script hash, which is the address of the token on the blockchain, the operation or the name of the method that you'd like to call on the smart contract, and args, which is going to be the arguments that you would like to have as inputs to this method. So in this case, it's just going to be, again, of an object with a type and a value, where the type is address and the value is the actual address. So just as we saw in the testbed, in the output, that's going to be the same as the value that's returned in the resolve of the promise. And so in this case, we've just taken out the result, because that's the value that we're most concerned with in this example, and we can just console log it here. So in the case that you've made a request to invoke read, but there was possibly an error trying to fetch this data from the blockchain, it'll trigger a rejection on that promise with the same error type object, and you can see here that it'll return with a type of RPC error, and you can read more about what the error was that prevented it from reading this data. So now that you've done an invoke read, let's take a look at what it looks like to do an invoke. So when you're calling invoke, as opposed to invoke read, where it doesn't require any user permissions and it's just reading information from the blockchain, calling the invoke method is more of a write method, similar to calling send, where all the information that you've passed as inputs to this function are going to be presented to the user, and the user can review it and decide whether or not they would like to sign and broadcast this transaction to the blockchain. So in this example in the testbed, we scroll down to the invoke section, and we filled out some of the same parameters like the script hash, operation, and the arguments. And in this case, instead of doing get balance, we're going to be calling the transfer method on this OEP4 contract, and as inputs, we're going to be including 3 input arguments, and the first 2 are going to be addresses, where the first is the from, second is the to, and the third is going to be the amount that you want to send. And there are some optional parameters here that let you adjust the gas price or the ONG price that you'd like to pay the fee for. And so at the moment, we'll just leave them as they are, because this is the standard fee that you're going to pay, and click invoke. And upon clicking invoke, it's again going to present you with a notification window where it's going to give you information about your dapp and all of these transaction details for the user to review, and then eventually reject or sign depending on what they would like to do with this transaction. So let's go down and have a look at what the code for this looks like. This is actually going to look very similar to using invoke read, but just the only difference is the return value in the resolve of the promise, and actually how it's handled in terms of the user interface for presenting the approval for this transaction. So you can see here that it's also going to take a network, a script hash, an operation, and a list of arguments. And when the promise resolves, it's going to return the same thing as the send method, where it's the transaction ID of the signed transaction that was broadcast to the network and to which node it was broadcast to. So that's the basic overview of the main 2 functions that you're going to be concerned with when interacting with smart contracts on the Ontology blockchain using the dapi for a wallet provider. So if you want to find this or any other tutorials about how to develop applications on Ontology, you can find all of these in the Ontology Learning Center by Tower Builders at learn.towerbuilders.org.